everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll do the comparison between single-phase induction motor and three-phase induction motor for their respective relative size. If we go for a similar parameters and similar specific loadings, then what may be the difference when we go for exact similar KVA rating? That difference in relative size will study in this video lecture. In same way, if we go for same volume or same size, then what may be the difference in the output rating between single phase as well as three phase induction motor? So now let us start for single phase induction motor. In case of single phase induction motor, we know that output coefficient CO, and it can be written as a 11 kW VAV, that is specific magnetic loading, AC, that is specific electric loading, and 10 raised to minus 3. If we go for similar specific loadings for single phase as well as for three phase, then specific magnetic loading and specific electric loading are similar in case of output coefficient for single phase or output coefficient for three phase. The only difference that is in the winding factor, that is kW. In single phase induction motor, the winding is spread over 180 degree, right? So distribution factor, that is KD, it can be written as sine of sigma by 2 and divided by sigma by 2. And we know that winding is spread over 180 degrees. So distribution factor can be written as sine pi by 2 divided by pi by 2, and ultimately it comes to 2 by pi. So distribution factor KD, that is 2 by pi. Taking full pitch coil, we are assuming that our coil is a full pitch coil. So pitch factor Kp is equal to 1, and winding factor, now it is a product of Kp and Kd. Kp we have taken as a 1. So winding factor Kw is exactly equal to the 2 by pi. Now let us substitute value of winding factor in our equation of output coefficient. So output coefficient now changed to 11 multiplied by 2 by pi multiplied by specific magnetic loading multiplied by specific electric loading and multiplied by 10 raised to minus 3. We have a volume that is product of D and L, that is known as the D square L, that is size of the machine. In case of D square L, we know that it is Q divided by CO. NS is our synchronous speed in revolution per second. And if we substitute value of CO, then our equation for D square L becomes Q divided by 11 multiplied by 2 by pi multiplied by VAV multiplied by AC multiplied by 10 raised to minus 3, and synchronous speed, that is NS. Now let us start for three phase induction motor. Output coefficient, again it is similar, 11 multiplied by kW multiplied by VAV multiplied by AC and multiplied by 10 raised to minus 3. As I said, that the difference between single phase and three phase, in case of output coefficient, only the difference is in winding factor. So for three phase induction motor, the winding is spread over 60 degree, and therefore distribution factor KD, it can be written as sine pi by 6 divided by pi by 6, and then it comes to 3 by pi. Again, we take a full pitch coil and pitch factor can be taken as equal to 1. and therefore winding factor, that is product of Kp and Kd, that is pitch factor and distribution factor. So Kw winding factor, that is exactly equal to 3 by pi. Now let us substitute value of Kw winding factor in our equation of output coefficient. So CO, that is 11 multiplied by 3 by pi multiplied by BAV multiplied by AC and multiplied by 10 raised to minus 3. Now we have a product D square L, and that is volume of the machine, and we know the similar equation, that is D square L is equal to Q, that is output rating, and divided by CO and NS. Now in this equation we have substituted value of output coefficient. So Q divided by 11 multiplied by 3 by pi multiplied by BAV multiplied by AC multiplied by 10 raised to minus 3 and multiplied by synchronous speed NS. Now for the single phase we have one equation for D square L. For 3 phase we have another equation for D square L. Now if we do the comparison, we are comparing the size of single phase induction motor with 3 phase induction motor for similar output. Comparing a single phase machine and a 3 phase machine with similar rating, and we have designed for the same specific loadings. So synchronous speed is same, specific loadings are same, and output ratings are same. Then we can compare the size of single phase induction motor with 3 phase induction motor. So we have a comparison. We take a ratio for D square L for single phase machine and D square L for 3 phase machine, and then we have a ratio that is 3 by 2 or it is 1.5. So now we need to conclude. So we take a conclusion from the ratio. We can take this conclusion as it is observed that D square L for single phase motor is 1.5 times greater than that of the 3 phase machine. So size of single phase induction motor is 1.5 times greater compared to that of 3 phase induction motor when we have a similar output rating and we have similar specific loadings. We have another conclusion also. In other words, output of single phase motor is 2/3 of that of the 3 phase motor for the same D square L. This can be interpreted as another way that if we go for similar size for single phase induction motor as well as for the 3 phase induction motor, then output rating of single phase induction motor compared to 3 phase induction motor for the similar size, it is 2/3, right? 2/3 output rating. So this way we can conclude for the size as well as for the output rating, we have compared single phase induction motor with 3 phase induction motor. So thank you for watching my video. Keep watching. Thank you very much.